Hello everyone, this is Mamberlin, and this lecture is all about face-centered cubic cell crystal system, but we will be focusing more on the calculations since we already did the lecture discussion on our just earlier we did that. So when we talk about face-centered cubic cell crystal system, this one is a type of crystal system where the unit cell is in the shape of a cube. This is one of the most common and simplest shapes found in crystals and minerals. Okay, so face-centered cubic unit cell. This one is it contains atoms at all the corners of the crystal lattice and at the center of all the faces of the cube. So we have here problems to solve some of the basic problems here, word problems. We have here for the problem number 1, gold crystallizes in cubic closed packed structure, which is also known as face-centered cubic cell structure, and it has a density of 19.3 grams per cubic meter. We have to calculate the atomic radius of gold in picometer or PM. Now, for the solution of this one, we have here the following. The first step is always, as always, we have to, from the density of the unit cell, we will be converting that into the volume of the unit cell and then the edge of the length of the unit cell. Then we all have the radius of the gold atom. Now, for step 1, okay, so we have the face-centered cubic cell, which is A equals 8 square root of 8 radius. This is the relationship in the simple in the face cubic center, the relationship between the edge of the length and radius. This is the relationship, all right, for face centered cubic cell. Now, the first thing that we need to do is we know the density. So in order for us, okay, the density was given, which is 19.3 grams per cubic meter. So in order for us to determine the volume, we find the mass of the unit cell. Remember that each unit cell has 8 corners and 6 faces, and the total number of atoms within such a cell is, we have here 8 by over 1 over 8 for face-centered cubic cell, plus 6 by multiplied to 1 half, and then that will have 4. And then the next thing that you need to do is find the mass of a unit cell in grams. So you have to find the mass in grams. You have 4 atoms, therefore 4 atoms in 1 unit cell multiplied to the 1 mole, and in 1 mole there is 6.022 times 10 raised to 23 atoms. All right. And then multiplied to the molar mass or atomic mass of gold, which is 197.0 grams, and that is in 1 mole. So we are arranging the unit in such a way that we can cancel it. So cancel this one. Let me use the red. Cancel the mole unit, cancel the mole unit, cancel the atom unit, cancel the atom unit, and then perform the operation, multiply, multiply, multiply. You will have 1.1.31 times 10 raised to negative 21 gram per unit cell. Now, we already have the gram, so we can find now the volume of the volume of this one. So to find the volume, we will have here volume is equals mass over density. This one came from this density is equals to mass over volume. All right. So you have to manipulate that formula, and then you will have the volume equals mass over the density. So mass is 1.31 times 10 raised to negative 21 grams. Then the density was given in the problem, which is 19.3 grams per cubic meter. Then cancel the gram unit on this one, cancel the gram unit. You will be left out with the cubic meter unit, and then divide that, you will have 6.79 times 10 raised to negative 23 cubic meter. The next thing that you need to do is, all right, this is step 2 here. We have, because the volume is length cube, we have to take the cubic root of the volume of the unit cell for us to obtain the edge length of the cell. All right, so you have to take the cube root of the volume, and the volume is 6.79. Okay, so you have here this one, the A, and then to find the edge length, that is, you have to get the cube root of the volume. Okay, so cubing the volume, that is 6.79, find the cube root on your calculator. You will have 4.08 times 10 raised to negative 8 centimeter. Now, finally, from this one here, we see that the radius of gold sphere, or radius of the gold sphere, is related to the edge length by this value here, which is A equals square root of 8 radius. And then since we are looking for the radius value r, you have to manipulate that and for us to find the variable for radius, which is a over square root of 8. And then the value of your a, or the edge of the length of the cube, which is 4.08 times 10 raised to negative 8 centimeter over the square root of 8. And then solve that, you will have 1.44 times 10 raised to negative 8 centimeter. You have to convert it into picometer. So all you need to do is 1.44 times 10 raised to negative 8 centimeter times 1 times 10 raised to negative 2 meters over 1 cm multiplied to 1 picometer. In 1 picometer, there is a 1 times 10 raised to negative 12 meter. Solving all of that, you will be able to cancel the units here. Cancel, 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 cancel. You will be left out with the picometer unit. And therefore, the answer is 144 picometer. Okay? And that is the answer, 144 picometer. Second sample problem for this one, we have the following. Silver crystallizes in cubic closed packed structure, which is again face-centered cubic cell, and has a density of 10.49 grams per cubic meter. Calculate the atomic radius of the silver and picometer. We have here the following again for number one. This is the value for, or the constant for face-centered cubic cell. This one you will have value 4 and then get the mass. And then that is to find the mass, convert the atoms into mole, then the mole into grams. So 4 atoms in 1 unit cell. And then in 1 mole, that is 6.022 times 10 raised to 23 atoms. Then the atomic mass of silver is 107.87 in 1 mole of silver. Cancel the units, cancel the mole unit, the atom unit, cancel that, cancel the silver, grams rather. No, cancel the mole rather, I'm sorry. And then you will be left out with, perform the operation, multiply, 7.16 times 10 raised to negative 22 grams per unit cell. And then find the volume through this formula, mass over density. You will have plug the value of the mass, which is 7.16 times 10 raised to negative 22 over the density. The density is given the problem, that is 10.49 grams per cubic meter. And then cancel the gram unit, you will have 6.8 times 10 raised to negative 23 cubic meter. And then again, since this one is in cubic meter and the relationship as always of the length cube, we have to take the cube root of this one, cube root of the volume. Take the cube root of the volume, that is this one, plug in the substitute the value, 6.8 times 10 raised to negative 23, getting the cube root, that is 4.08 times 10 raised to negative 8. And then the relationship again, because we are finding the radius, that is r equals a over square root of 8. Plug in these values here, 4.08 over square root of 8. You will have 1.44 times 10 raised to negative 8 centimeter. Convert the cm into picometer, that is 1.44 times 10 raised to negative 8. And then in 1 cm, there is 1 times 10 raised to negative 2 meters. And then in 1 times 10 raised to negative 12 meters in 1 picometer. So cancel, 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 cancel. You are left with picometer. Perform the operation. You have 144 picometer. All right. So that is how you find the radius in a face-centered cubic cell crystal system. Thank you.